Yeah, good morning, class. I hope everybody is doing fine. It is the fifth of our lecture series on ISC 152. This morning we want to look at basic electronics. The project work that has been assigned you is on basic electronics. You are to construct or build an FM transmitter. Now you require some basic knowledge in basic electronics to be able to construct or to build this FM transmitter. And so this is just an introductory lecture to the various components that we may use in constructing our FM transistor. My name is Asem Humphrey Dake. Now the objectives of this lesson, as we can see from the CLOs and then the CLIs, we are to identify and name some basic electronic components and appliances, as well as also show some basic knowledge of their functions. We see this in the NTS 2C page 13 and 21. We also, as the course learning indicators, would have to construct or sketch devices that show named parts of electronic devices. Again, you have to show models of electronic devices and the energy source that they use. And finally, we are building an FM transmitter. Ladies and gentlemen, it is very important to know the definition of electronics, since the topic or the course segment that we are discussing deals with basic electronics. Now, electronics is simply an applied physics that deals with the study of flow and control of electrons and the study of their behavior and effects in vacuum, gases, and semiconductors, and with devices using such electrons. So what we are basically saying is that this is a branch of physics that looks at devices controlling the flow of electrons in gases, in semiconductors, and other devices that use them. Now, the control of electrons is actually accomplished by devices or electronic components in the way or in the form that they may, as it were, resist the flow of the electrons. So we are looking at the modes or forms of electron control in these devices. The devices would have the ability to resist the flow of the electrons. They may carry the electrons across. Again, they may select which type or how many electrons should go through the given device. They may steer them. If we say steering, it's just like being behind your wheels, the car, and trying to control the steering wheel. So electronic devices or components may steer the electrons they control the electrons. They also may switch an electronic device on or switch it off, store some electrons, in other words, store charges, and also manipulate those electrons and exploit them as well. So the modes of electron control in electronics range from resisting, carrying, selecting, steering, switching, storing, manipulating, and exploiting of the electrons. Now, many a times we confuse electronics and electrical. We confuse electronics and electrical. So we want to look at the difference between the two. Now, the electrical deals with the flow of the charge through metal conductors. Electrical deals with the flow of the charges or the electrons through metal conductors. But then electronics deals with the flow of the charge through a non-metal conductors, which we sometimes describe as semiconductors. So whereas in electricals, electrons move through conductors, in the electronics, we have these electrons moving through semiconductors, and we shall look at what these terms mean. We have to distinguish amongst conductors, insulators, and semiconductors to be able to get this clear understanding of what we mean by conductors, insulators, and semiconductors. Now, on your slide, you see some beautiful drawings showing some important things about all substances that we can lay our hands on earth. Now, to start with, we want to say that every substance has 3 layers. Every substance has what? 3 layers. And the layers include the conduction band, the forbidding gap, and the valence band. So 3 layers: conduction band, forbidding gap, and valence band. So if you take a look at the insulator, you realize that it has a conduction band, it has a valence band, and it has some forbidding gap, which has been described as large band gap. If we take the semiconductor, you also see similar arrangements. There is a valence band, there is a small forbidding gap, and a conduction band. When you take the conductor, what we see is an overlap between the conduction band and the valence band. And so we see that on our slides, from the conduction band, some black lines move direct into the forbidding gap, whereas some red lines move from the valence band into the forbidding gap. And these 2 lines, that's from the conduction band and that's from the valence band, intersect inside the forbidding gap. and that we see as shown on the slide on the right hand side if you are looking at your slides. Now, for these three materials, that's the conductor, insulator, and then the semiconductor, they have electrons in the valence band. There are electrons found in the valence band. Now, when we say valence, I hope those of you who have done some chemistry knows that it is the outermost shell of the atom. So in the outermost shell, we have some electrons in that shell. Now, if you take the conductor, the valence electrons, or the electrons found in the valence band, they have the ability to move into the forbidden gap. That's shown with the red lines going there. And it also means that if there were electrons in the conduction band, they could also fall to the forbidden gap, making that place a no man's land. Thus, free electrons move from the valence band, and because there is no forbidden gap, they are able to move into the conduction band, and there can be conduction of electrons. Hence, we call them conductors. So conductors conduct electricity, or they allow electrons to flow because there is no forbidden gap, and they have free electrons that can easily move from the valence band into the conduction band. We can liken this to people who stay at the border. In fact, they don't need passports to cross to the other country. So if you are in Ghana, for instance, and you stay at Aplau and you want to go to Togo, you don't need any passport to go. In fact, because the people know you, you can just cross, go and come, go and come. And that's how the conductors behave. Now, if you come to the insulator, there is a large band gap or forbidden gap, which means that if there were electrons in the valence band, those electrons need some amount of energy to skip the forbidden gap in order to get into the conduction band for conduction to take place. And because that amount of energy is difficult to come by, no electron can move from the valence band and cross to the conduction band. Hence, insulators do not conduct electricity at all, or they do not allow electrons to pass through them. Now, if you compare the band gap or the forbidden gap of the insulator to that of the semiconductor, you realize that the semiconductor has just a small band gap or forbidden gap. Hence, electrons in the valence band can get that energy to jump over the forbidden gap so they could get to the conduction band to conduct. Now, this type of energy is obtained by thermally exciting the electrons there. When they are subjected to heating, they get that amount of energy, and then they can jump and go into the conduction band for conduction to take place. So that if we get back to the conductors, you realize that already free electrons are moving. They are moving from the valence band into the conduction band because there is no restriction. What it means is that at high temperatures, movement of electrons will be faster, because when particles are subjected to heating, they gain kinetic energy, or the average kinetic energy increases, and because of that, there will be a lot of collision. If there is collision, it means the electrons will not go. So usually conductors do not conduct electricity at high temperatures. That's how come those old sound systems and amplifiers, when you are playing them, you have to put fan on them so that they will be able to get optimum temperature to operate. If you take the fan off, they will work up to a point. If they become very hot, they are going to stop working, and that is how conductors behave. On the other hand, since we have said that for insulators, electrons in the valence band would need so much energy to do that, and that energy is something you cannot get, then insulators cannot conduct electricity. But then when you come to semiconductors, what it means is that they can conduct better at high temperatures, because the electrons in the valence band need to be thermally excited to get to the conduction band. Now I would have to look at the differences per the definitions that we have given and go on to look at the examples under these three materials. So under conductor, we can see conduction band and valence band overlap each other. Okay, and now when we come to the insulator, conduction band and valence band are separated by at least 6 electron volts. When you come to the semiconductor, conduction band and valence band are separated by at least 1 electron volt. Electron volt is the energy that you need. Okay, so 6 electron volts, meaning that for electrons in semiconductor which are found in the valence band, they need 6 electron volts of energy to be able to move from the valence band into the conduction band. When you come to the semiconductors, they need just 1 electron volt to escape the forbidden gap so that they can conduct. Now conductors conduct at low temperatures, as we have already said. Then if you come to the insulators, they do not conduct at all. And then that of the semiconductors, they will conduct at high temperatures. This explains why devices that are usually made of semiconductors do not actually need fan to make them work. And so your laptops, you can even put them on for a long time, because most of the components in the laptop are made of semiconductor materials. The same applies to your plasma TV and other devices that we'll talk about later. So examples of conductors include copper, mercury, silver, aluminum, water, acid, human body, metallic salts, and charcoal. In fact, water here is not pure water. It should be water which has dissolved mineral salts in it. Then we have examples of insulators: wood, rubber, glass, ebonite, mica, sulfur, and dry hair are insulators. Under the semiconductors, we have silicon and germanium. In fact, cotton wool, and then the marble, sand, paper, ivory, moist air are all semiconductors, but may contain either of germanium or silicon. And so those are some examples that you can cite when we want to look at the three branches of electronics. When you study electronics, there are several branches that you can delve into, and they include: 1, integrated circuit electronics. You can do semiconductor device electronics. You can do what we call optoelectronics. You can do digital electronics, analog electronics, micro electronics, and nano electronics. So these are the branches, so many avenues that you can delve into once you study electronics. And these are very lucrative areas that students would want to explore. Advantages of electronics. Now we know that due to electronics, we have so many easy life applications. ATM, you don't have to go and queue at the bank to get your money. You can just slot in your ATM card into an ATM machine, and take your money and go home. Plasma TV makes watching TV very exciting. Your computers as well, mobile phone, and all these are some advantages of electronics, as we see on our slide. Now we want to look at electronic components. So for instance, if we say television, or we say plasma TV, or we say ATM machine, or we say mobile phone, these devices have certain materials inside, or certain particles inside, or substances inside, which make them work the way they are working. And electronics, these devices are called components. And so if we talk of components, we say an electronic component is any basic discrete device or physical entity in an electronic system used to affect electrons or their associated fields. So soon we'll be mentioning some of these components, and we get to know what they do in the various appliances that we'll be mentioning. So we have resistors, they are components, inductors are components, diodes are components, transistors are components. So many of them can be mentioned, as we see in our slide. Now electronic components can be categorized into two. There are two classes of electronic components. So we have active components and passive components. Please take note of this. The components we have mentioned, that's the resistor, the inductors, the transistors, and so on and so forth, we can classify them into two main groups: active components and passive components. So if we look at the active components, we say they are part of a circuit that rely on an external power source to control or modify electrical signals. Control or modify electrical signals. Examples are transistors and diodes. Now when you look at the passive components, then they are parts of a circuit that do not need an external power source to function. These components use some other property to control the electrical signal. Example, resistors, inductors, and transformers. So we now know that when we are mentioning components of electronics, then those components can be classified into two: passive and active components. So these are some pictures showing the active components, and you see the transistor, you have SCR, and you have a diode. Please go and look out for the meaning of SCR. If you look at it, it resembles a transistor. It has three terminals like the transistor, and so they may have something in common. So go and look up for the meaning of SCR. We would have to discuss this later in our physics lessons. Now when you look at the passive components, capacitors come in, resistors come in, and inductors also come in. So these are passive components. These are active components. Similarly, we can also talk about more of the passive electronic components. But in this slide, our interest is to look at the component and look at its symbol, electronic symbol, because most of the things we'll be doing would have to do with drawing circuit diagrams, which would include some of these things, but we don't write them in this form. We put them in symbols. So if you look at this, this is the symbol of a resistor. A symbol of a resistor. This is the symbol of a capacitor, and this is a sensor, and this is an inductor. Go back and look at what we have there. So resistor, capacitor, and this actually a sensor, and then we also have the inductor. Now we take them one by one. So this is a transistor. A transistor is a three-terminal device that regulates current or voltage flow and acts as a switch or gate for electronic signals. It has three terminals. So transistors are identified by their three terminals as shown in the slide. So this is a transistor, the three terminals, 1, 2, 3, and if you look carefully, each terminal has a name. We have CBE. The C means collector, the B is base, and E is the emitter. Now whichever way, there are three of them. So if you look at the one down here, is emitter up, base here, and collector here. And in this, we have collector, base, and emitter. Different types of transistors exist, but the two main ones that we know and we shall be talking about is the NPN and PNP transistors. So this is an NPN. If you can see that N-type, P-type, and N-type, so we call it NPN transistor. And we also have the PNP transistor. This is also a typical example of a transistor. It comes with emitter, base, and collector. Soon we'll get to know how to identify these three terminals, because it is not the case that the base is always in the middle, the collector here, and then the emitter here. You identify this very soon. Now the symbol for the transistor as shown in your slide is what we have in there. Functions of components in an electric or electronic circuit, and we also want to look at resistors. So what we know is that resistors, they prevent the flow of current, or they prevent the flow of electrons. Okay, resistors prevent the flow of current. And so if you take a look at this, then these are some examples of resistors. They come with color bands. You can see very beautiful color bands, and these colors on the resistor, identify them by their magnitude, their sizes, so that you get to know that this is 22 kilo ohms, this is 50 kilo ohms, or 40 kilo ohms, or 1 ohms, or whatever. I mean, resistance is measured in ohms. So the colors tell us what value they possess and how much they are able to prevent the flow of current. Aside that, we may look at other things like how big they are and how thin they are. Big will give you larger surface area, and thin means a small passage route. So that if you have a wire which has a narrow path, that's a thin wire, then the movement of electrons inside it will be difficult than when electrons will have to move through a bigger wire. And these are all associated with resistance. It is resistance that brings about heating up of a system. Like you have your iron. The iron contains some elements which is very thin, and passing electrons through it makes it difficult for electrons to go, and so by that the element in the iron becomes hot and you can use it to iron. The same thing applies to your heaters, but the point is that any device that uses electricity would oppose the flow of electrons and so becomes hot at the end of the day. A device that prevents the flow of current or charges or electrons is referred to as resistors or resistor. Now this is the symbol for a resistor. Now this is very important. There are two symbols here, and so when you are drawing, make sure you draw properly. Now we know that you have to do something like this and put your wires at the tail end of both sides. Should your line cross into the device, then you have not drawn a resistor. It could be a fuse that is blown, or if you do this, then this becomes a fuse instead of a resistor. So please be careful when you draw this electrical and electronic components. Inductors. Inductors are sometimes called coils, or they are called choke, or they are called reactors. And an inductor is a passive two-terminal component that stores energy in the magnetic field when current flows through it. So basically, when you have a wire and you try to wind it around to form some coil, then we say we have an inductor. So in your slide, you see some inductors that have been made and beautifully made. These things you see here, once you connect their terminals to power source like a battery or a cell, you see that it generates electrical magnetic field in the coil, and when you slot in any magnetic substance, that magnetic substance becomes a magnet through electromagnetism or electromagnetic induction. And so please, we know that coiled wires can be used in making magnets, as the case may be. We normally say solenoid. We use solenoid to do that. So we may also call these inductors a solenoid depending on how it has been coiled. The symbol for the inductor is what we see on our slide, and you should know how to draw this as well. You should know how to draw it. The number of rings that you draw does not really matter, but again, it matters when you have to use it for something. For instance, if you take the fan that is rotating will have a coil inside. The number of coils will determine the kind of energy that will be exhibited by the fan, such that if the fan even spoils and you have to go and repair it, and it has to do with the coil, so that they are not able to get the number of coils or turns of the coils, then the fan will not work. So specific number of turns are required for the functioning of given devices. Next one, capacitor. A capacitor is also a two-terminal passive electronic device that stores electrical energy in an electric field. So you can compare this with the inductors. The inductors will store the energy in the magnetic field, and these ones store the energy in the electric field. Capacitors are very common. If you open a UPS of a computer, you find a number of capacitors inside. Similarly, this traffic light arrangements, you see capacitors in there. Even your phone, some of the phone batteries may contain capacitors, which help to store charges because you have to charge your batteries and so on and so forth. So capacitor is a two-terminal passive electronic device that stores electrical energy in an electric field. And we have various types. They look very beautiful. If you look at your picture, you see that these are beautiful, components that we see in our electrical and electronic devices. The symbol for capacitors are as shown, so many of them. The commonest of all is the two power lines having same height and with the two horizontal lines on opposite side of the capacitor or the power plates. So take note, drawing this, you need to be very careful, because if any of the lines are shorter, then it turns into a cell or a battery, which we also know that batteries provide energy for a circuit system. It's important we look at diodes as well. A diode is a semiconductor device that allows current to flow through it in only one direction. Now, all these things are meant to bring your minds to the fact that in constructing our FM transmitters, we may need some of these things in there. We may need a transistor, we may need a capacitor, we may need a resistor, and we may need an inductor. All these things, when put together, each of them playing a specific role or function. For instance, resistors, preventing or trying to prevent the flow of electrons. Inductors, providing energy in the magnetic field. Capacitors, storing energy in the electric field. And also the transistors, sending in and receiving the electrons here and there, would make your FM transmitter work perfectly. So a diode is a semiconductor device that allows current to flow through it in only one direction. So we have some examples of diodes, so many of them. At the JHS and the basic level, students will be required to identify some of these things and even relate to their symbol or the electronic symbols. So take note. Typical example, this LED light emitting diode. We have the pin diode, the step recovery diode, the Zener diode, and so many others that we have here. All diodes, what they do is to allow current to flow in only one direction. And these are the symbols. Please look at the symbols and look at the devices, the components themselves. Electronic devices. So we are done with the components. We are now looking at the devices. A device depending on the principle of electronics and using the manipulation of electron flow for its operation. Now, if you take a device or electronic device or an appliance, you realize that the things that we have mentioned, both the active and then the passive components, are present in that device. So, depending on which active or passive component there is in the device, it will either manipulate the flow of the electrons by way of resisting it, steering it, or exploiting it, or storing it, and so on and so forth, as we saw in the first three slides. So electronic devices are usually instruments or equipment or smart equipment like Bluetooth speakers, toys, and etc. composed of various components. They are composed of various components. Every electronic device may have two or more of the components that we have mentioned. examples of electronic devices or appliances, then you have this beautiful, display of a laptop is an electronic device. Sound system will be an electronic device. Baby Einstein. Now, many of you would not know this Baby Einstein because you were not babies when you were born. Yeah, some of us, as soon as we were born, we started eating banku, kukunte, and so these things, we can't find it. But those of us who, we were taking breast milk, and at the same time, from the thermos flask and all those things, we have seen this before. So Baby Einstein is not common to everybody. Yeah, but today all of us are using mobile phones. Mobile phone is also an electronic device or appliance. Then we have a modem. Modem is also electronic device. Amplifiers, electronic device. And then we have the microwave oven. So these are some examples of electronic devices. We may distinguish between electronic device and electronic components, as has been said already. The components are inside the devices. So take note, electronic components are usually instruments. Devices are usually instruments, and smartphones and speakers, so many of them. But the components are usually integrated circuits, triodes, diodes, capacitors, resistors, LED chips, and so on and so forth. Take note. And are mounted on integrated circuit boards, which sometimes people call it motherboard, and so on and so forth. So when you take your sound system and you dismantle it, you find a certain board on which lies so many of the components. You see resistors, you see transistors, you see capacitors, and many other components. So a laptop is an electronic device, and a transistor is electronic component. Now, we also would want to be interested in knowing the difference between electrical devices and electronic devices. As scientists in the making, or science teachers, some of these petty mistakes we should not be found to be doing or making them. So you should know what an electrical device is and know what an electronic device is. Now, the comparison will be based on basic definition. And so if we defined electrical device, then we say it's a device which uses electrical energy for performing work or performing the work. They will use electrical energy to perform work. But when it comes to electronic device, a device which controls the flow of electrons for performing a particular task. So here there's some control. There's some control of the movement of electrons in the electronic device, but in the electrical device there is no control. Again, materials used in electricity or electrical devices include metals, mostly metals like copper, silver, aluminum are used for the conduction of the current. But when it comes to electronics, it's semiconductor materials like silicon and germanium. Similarly, operating principles. The electrical device converts the electrical energy into other forms of energy, but for the electronic device, they would use the electrical energy to perform a function. In terms of current usage, electrical devices use alternating current and electronic devices use direct current. And so electrical devices may need electricity from Akosomo direct, but electronic devices may use the direct current like batteries and so on and so forth. So that even if you are charging your phone, Okay, you plug your charger into an outlet to charge your phone. The charger is converting the alternating current to direct current, that which the phone will use. Again, in terms of voltage, electrical device works, or they work on high voltage, whilst the electronic device work on low voltage. And electrical device consume more power, whilst electronic device consume less power. So all the things you see here are all electronic devices or appliances in our homes. We have mentioned them already. All these are electronic devices. Function and operating principle of plasma television. Now, our interest is to also identify how these electronic devices work in the house. Okay, how they work in the house, or when you have them, how the principles upon which they work. And so we want to take one of them, that is the plasma TV, and look at how it works. In fact, the plasma TV, as we all know, has a screen, and on the face of the screen we are told there are some codes. And so we said the picture made by a plasma TV is made from an array or grid of red, green, and blue pixels, microscopic dots on squares. So the screen of the plasma TV has such dots, small, made up of green, red, and blue. Each pixel can be switched on or off individually by a grid of horizontal and vertically mounted electrodes. So on your slide, you see this is the vertical or vertically mounted electrodes, okay, and then the horizontal ones go this way. They go this way. So these electrodes, both horizontal and vertical ones, have the ability to touch a particular pixel, whether red, green, or blue. Now, suppose we want to activate one of the red pixels, and in that case somebody is wearing red and wants to take a shoot, video shoot, and so that red has to appear on the screen. And so suppose we want to activate one of the red pixels, the two electrodes leading to the pixel cell puts high voltage across them, causing it to ionize and emit ultraviolet light. Now when that happens, we see that the ultraviolet light shines through the red phosphor coating on the inside of the pixel cell, and the phosphor coating converts the invisible ultraviolet into visible red light, making the pixel light up a signal red as we see here. So this would bring the picture to the view of the person. And these are some of the ways we may describe how the plasma TV works. We will send a video on the operational function of it so that you will be able to relate it to what we have just said. Now, you would also have to work on other devices as well. Look at the operating principle. But on our slide, we see tools for electronics, or hand tools for electronics. We are doing all this because your project work is based on this. You are supposed to come out with an FM transmitter, so you may need some of these tools to be able to do that. So we say these are tools that are used to assemble electronic projects. Basic hand tools, we have driving tools, soldering tools, splicing tools, boring tools, cutting tools, and auxiliary tools. And you see them in the picture. We'll take them one by one. We are just about closing. But if you look at the pictures on your screen, then we can confidently say that we have seen these ones before. These are pliers. Similarly, we have seen soldering iron, we've seen multimeters, we've seen screwdrivers, we've seen splicing pliers. These are not common. And then the wire cutting plier, they are not too common, but they are there. And we also have the boring tool. So some of these tools, you may require them to build your FM transmitter. Question. Now, you are supposed to write down all questions that you think would explain, when answered, would explain all the concepts that we have just discussed. And you send them to us via the various platforms. The KNUST platform is the official platform for these, teaching and learning, as well as assessment, processes. Again, we have the Google Classroom. You can also do that through the WhatsApp lines and the Telegram, adequate platforms. But we also have questions for you. So our question for you is that name any two electronic hand tools under the following headings. So you have driving tool, splicing tool, boring tool, cutting tool, auxiliary tool. Please do that. We will give you dates of submission so that you do that in the nick of time. Assignment number 2, state the function and operating principles of each of the following household electronic appliances. So one of them, refrigerator, microwave oven, air conditioner, mobile phone. You have to state the operating principles of each of the following, electronic appliances. Mind you, we live in our homes with these devices. We know what they do, but we don't know how they do what they do. So this work or this assignment is to help you understand the operating principles of the devices which help you in your homes. COVID-19 is real, and we keep reminding you that Wesley College is proud to have students like you, but then we are also praying fervently that you come back and join us in college when all these issues concerning COVID-19 are over. You are to observe all the safety protocols, making sure that you avoid a lot of social contacts. Also try to wash your hand with soap under running water, and also use the face mask or the nose mask, and as much as possible stay in your homes when you have nothing doing outside. The virus does not move, human beings move. So if you keep still in your home, the virus cannot come to you. Have you seen the virus misbehaving? Yes. So please do that. Thank you very much, and see you some other time. If you go through